Hey folks, hope you are doing well. Uh, in today's video, we will cover or we will try to understand the function option pattern, which is one of the pattern that we use in Golang in big libraries, which enable us to basically whenever we are passing any arguments to create whenever we are passing any arguments which are optional arguments, it helps in keeping them in a maintainable way. um, what I am saying right now, it will be clear after I walk you through this video. So generally what happens is that in many of the places you have seen that whenever we are initializing any object or something, we are passing the Go constructor will be having like lot many arguments, right? And most of them are zero value, which you don't actually require. But since the function define those arguments, we have to necessarily pass them, even though they are zero value. So what is the problem with that is that it is very hard to read what we are passing, and sometimes it become nightmare when we want to add a new field. So I will walk you through on what I mean by that. It is hard to extend and hard to read, and what is the solution we can implement using function option pattern that enable us to which enable for better readability and helps in extending it in a better way. So let's suppose that by going with the old approach, let's say old implementation, I will say it contain address, port and buffer size. Okay, consider that this is a struct that I have defined right now, which contain these many fields, and I want to initialize let's take these 4 fields. Now what is the way we do is that whenever we want to create a new object of old implementation, is that we do this way generally. So what it is saying is that I will call this function new old implement, which is implementation, and passing address, port, timeout and retries, right? So and when I pass that, it will return me an object of old implementation. So you can consider it as an old implementation, right? So now how do we create an object here is that we will say old implement, and we will try to pass this thing, right? So and when we try to print, and we can print it using fmt library. Now if you see, what we did here is that we created an object of old imp and using a function new old implementation, and we pass these variables, not variables but arguments to the function, and then we are printing the fields here. So if I run this code, go run, so it printed the values it contain. Now I mentioned 2 points at the start that this existing pattern is difficult to read and hard to extend. So what I mean by that is that if you look at these 3 things, right, we don't know what is this, what is that, and what is this, and all those things. It is difficult to understand what these values are. Yeah, definitely hovering over it can helps us understand, but if you are looking it directly, you can't basically able to understand what these values are and what fields are being assigned, these values are assigned to which field. So this is one thing which is basically hard to read and hard to extend. What I mean by hard to extend is, let's say tomorrow I am saying TLS, I am adding a new field. I require a new field in this struct, which is TLS. To basically initialize or have value in this field, I have to add this in the function as well, right? But before that, let's say there are multiple places we are using this function. We'll implement 2. So now this is just an example. So I am this can be any of the function that we must be using. So think of this way that you can think of that function is when you are enqueuing to any queue, right? You must need to pass some fields before enqueuing it, like consumer name, what is the UID of that message, and all those things. This whole example is just for understanding purpose of how the function option pattern works and where we can use it. So if you see, as I said, that this is one of the instance of old implementation, and these are other two instances of old implementation, right? Now tomorrow, if I say I want another variable in this function, which is TLS, I need to pass TLS in it. So the problem happens is, let's say I have to make a change in this new old implementation as well, and so that I can initialize this TLS variable, TLS field of the old implementation. Now, as I do this, I have to change the functions, all the places where this function is being called. So if you see that I am seeing the error here right now, this is because it require an additional argument now. So this is easier right now to make the change, because all the calls are in the single file and there are only 3 calls here. But it get problematic whenever there is a bigger code, so we have to make the changes in lot of the places, and the problem with that is that sometimes you miss something and it can cause error, and then sometimes it also increases the cognitive load on the, reviewer has to review different files now. Like instead of just this simple change, all the files which are referring to this function has to be reviewed, because those are getting changed. So this is the problem with this approach. So how we can tackle it so that we can have a better readability, and we can able to extend it in a better way. So here comes the function option pattern. So I will say new implementation. I will define a struct so again it will contain, let's say it contains only these two things right now, right? So what I will do here is I will use function closure. So function closure in Golang is, if I read the definition, it is basically says that Go functions may be closure. A closure is a function value that reference variable from outside its body. The function may access and assign to the reference variable. In this sense, the function is bound to the variable. Okay. For example, the adder function returns closure. Each closure is bound to its own sum variable. Okay. So what is happening here, right? If you see this function adder, what it is doing, it is basically having a variable, and then it is returning a function and bounding that function to this and bounding this variable to this function, right? So this is what it is saying. A closure is a function value that reference variable from outside its body. So sum is that variable right now, which is being bounded here. So if you see the main code, right, we are assigning, we are creating a POS variable with adder function. So what will happen is, now this is the function. So whenever I call POS 0, so since sum is 0 initially, so it will return 0 only. When I will do 1, now sum is again 0, it will do 0 plus 1, it will return 1. Now the sum is set to 1, and I am passing 2, so 1 plus 2, it will return 3. Now sum is 3 and I am again passing 3, it will return 6. So if I run this, it will return this. Now if I pass 4, so sum is 6, 6 plus 4 would be 10. So this is how the function closures work. Now how we can utilize this in our in our code is that what we can do is we create a type called as options. Okay. What it will do is it will take new implementation. It will whose type would be this, who's basically taking, we are defining a type called options. Whose type is this, right? Its type is function basically. So now what we are saying is that we are defining a, let's say, with timeout. What it will do is we will pass timeout.duration, and it will return options. and timeout. Wait, something is wrong here. End dot timeout option, the implementation. Oh yeah, timeout field is not there. Okay, so let's right now not use that. Let's first work with this approach only. So as the old implementation, I am creating a new implementation. So let's have this new implementation function block. Right now I'm not defining this. Okay, so nothing new has been done here right now as of now. So if you see, this is the same thing we did for old implementation as well. Just ignore, we can comment this code as of now. So we are defining new implementation. We have two fields, address and port, and this function is returning the new implementation object. So if I create new implementation object and try to print it, it is printing these things, right? Now, how, let's say if tomorrow I want a timeout here, right? If I want timeout in this, let's say time.duration. So as we remember that in old implementation, we have to make the changes in all the places if I'm adding timeout here, right? But instead of doing that, what we are doing is we are saying that we will create a new type called as options, and whose type would be a function, it's a function closure, which is accepting new implementation as an which is accepting new implementation object, right? Pointer to new implementation object. Now what I will do here is that I will define the options like this. So we will define a function called as function with timeout. Now what it is doing is that we will pass a variable outs, we are passing a argument d with timeout, and the d is assigning to the new implementation variable. Since it's a pointer, so it will assign to the same underlying variable. So similar to that, if I also do retries, I can add the similar implementation here. Now what is the thing here is that we have to also take now we are when we are initializing this object, right, we have to supply the options that we want to add, that we want to basically add in this struct. So what we will do is we will use vardic function here. Basically what it is that it takes the variable arguments. So now option is of type now option type is a function. So if you see here, so what we will do here is that we will say, let's dock it. And so now what it is doing, what this is doing is that it is assigning address and port and creating a object of new implementation. Now for other optional, it is checking if there are any options that are being passed here, and if there are any options, it is calling those options and assigning the value and basically assigning the assigning the value in the respective field. So with timeout will assign the timeout of that struct, and retries will assign the retry of that struct. And since it is passing the pointer, so underlying the addition is happening in the same underlying struct. So when I'm returning this n, if the values are being passed, it will have those values as well. So if I do here like new implementation timeout right now, so let's see, do we see anything? It won't print anything because we have not defined anything here, right? So but let's say if I create another new implementation method with timeout and with tries and try to print it now, so it is printing 10 seconds and 3. Let's say tomorrow I want to add a buffer size here. So again I have to define an option here with buffer size, and while creating the another implementation which uses that option, I do this way. So it is now printing this. So you see the benefit, right? The how it is easier to extend using the functional option pattern. You don't have to change this new implementation and new implementation 1. You just whenever you are adding any additional field in this struct, uh, because that is only required for new implementation too, so you just define it with an option and then it will be set there. So this is how we use the functional option pattern to make it extendable and easier to read. Like it will also telling us, like as I said, there is a readability is a concern here, but right now if I look at the code, this piece of code, I know these are the default values. For this we have not defined defined them as an optional argument, but for these value we can easily know what we are setting. We are setting the timeout, we are setting the retry, and we are setting the buffer size. So this is all about functional option pattern. So yeah, that's it. Thank you.